Okay, so first let me explain what we're trying to do. So what we have here is a line segment. I'm just gonna draw it without the grids, but I'm gonna label the numbers with the coordinates like this. Okay, so we're trying to partition or split a line segment in a way that the length from AP, let's say P is somewhere here. I'm just guessing where that is, okay? I'm just kind of approximating. We don't know where that point P is yet. But we do know that we want the ratio of these two smaller slices to be 3 is to 2. So 3 is to 2. That's what we mean by 3 to 2 here in the problem. Okay, so in real life, let's try to make sense of that. So let's say I give you and your friend a pan pizza, a circular pan pizza, and then I came back and I was like, they're all gone, no more pizza slices. And then you tell me that, oh, miss, we ate the whole thing in a ratio of about, 3 is to 6. So what does that mean? How many original slices were there at the beginning? Not 6. They ate it in a ratio of 3 is to 6. So there were 9 total slices for the whole pan pizza, right? Okay, so that's what basically is happening here. We have a stick, we have a long stick, okay, and we're trying to split it or cut it down somewhere where the ratio is 3 parts goes to one of the longer, 3 parts goes to one of the sticks, and then the other one, the other pieces, has 2 parts of the whole. Okay, so in other words, how many equal pieces does the original stick have? So if the ratio is 3 is to 2. 5, because 3 parts goes to the longer piece, 2 parts goes to the other, so there's a total of 5 parts in the whole stick. Okay, so what we're going to find is where is that point, so we can split it in that ratio. Okay, so now let's follow the steps over here. The first step is, so step 1, find delta x. Change in x pretty much is when you subtract the x numbers. So that triangle means change in x. So the formula goes x2 minus x1. So let's label them. Your x2, okay, this is your x2. So that means its partner will be y2. And this is your x1, and it means the partner will be y1. Now, can I switch them around? Can I say that point B will be my x1? No. Why? Because it's called a directed line segment. You see that word directed line segment over here. So in other words, imagine you're commuting and you're taking the bus. The bus does not take the same route coming back, and going to the destination, right? So it goes in a different route. So the directed line segment starts from A, goes to point B, and follows just that direction, but it doesn't go back. Okay, so they're not interchangeable. All right, so let's get the difference between x2 minus x1. x2 is 6. Take away, what is your x1? 3. So final answer is 3. Very good. Now let's find delta y, or the change in y. So earlier we paired the x, now we paired the y value. So what's the y value here? 8. Take away 2. Okay, so 8 minus 2 is 6. So that's step 1. Now let me pause and ask you, do you have questions about step 1? The only possible reason you could get that wrong is if you do it in a different order. Remember, it cannot be interchanged. So you always go ending point minus beginning point. All right? Next, let's do step 2. Step 2 is we're going to change the ratio 3 is to 2 into a percent or a decimal. Kind of like my pizza analogy earlier. So how many pieces are there in the first part? 5. The whole is 5. And then we take how many pieces we have in the first one, because we're going from A to P in that direction, so 3. Okay, so let me explain it again. The 3, or the numerator, came from the first number in the ratio, and then the 5 came from adding them up. So 3 plus 2 is 5. Okay, now let's do step 3. But before that, can you help me change this to a decimal? Point, how much? 0.6, correct? Because 5 times 6 is 30, so 3 divided by 5 is 0.6. Yeah, in the calculator. Okay, so now let's go to step 3. Once you have steps 1 and 2, you can now find the answer in step 3. So let's follow this formula over here. It says x1. So what's my x1? 3 plus the ratio that we got over here, which is 0.6. So that's the part highlighted in white, means a over a plus b is the 0.6. You times that by the delta x, or the x2 minus x1. So what was our x2 minus x1? 3. Okay. So let me explain that again. This is your x1 plus the decimal from step 2, 0.6. You multiply it by the first one, which is x2 minus x1. Okay. So what's the total here? Let's do a calculator for that one. Help me out. You have 4.8. Good. So you have to multiply here first. So 3 times 0.6, that's 1.8. And then you add the 3, so it will become 4.8. When you're using your phone calculator, be very careful because sometimes the phone calculator does not recognize PEMDAS. So in a calculator, what I would do is I times these two first, and then whatever I get, I add 3. I work backwards if you're using a phone calculator. Okay. 4.8, honey. All right, then let's find the last one, the y value. So y1 is how much? This is y1. So 2 plus, and then use the same decimal, and then copy the y2 minus y1 here, which is 6. Okay, so let's do that again in a calculator. If you're using your phone calculator, multiply first 0.6 times 6. After that, you add 2. And you should be getting 5.6. Yes, my dear? Yeah, the pass is there. Okay, so let's see if that makes sense in the problem. 4.8, 5.6. Let's graph it. 4.8, 5.6. So this is 4, a little bit less than 5, and then 5.6, so somewhere here. There you go. So this is about 4.8, comma 5.6. Okay. The only reason it will not make sense if you come up with points that are not even in the segment. So some students this morning were getting like negative 1.2. And I'm like, wait a minute. Your negative 1.2 is here. It's not even part of the segment. Then we already know. We can already say that that is wrong. So they went back in their calculation and they said, oh, miss, my calculator added 3 plus 0.6 before it times it by 3, which is wrong. Okay? Which is wrong. Okay, so I'll pause for like 15 seconds. Do you have questions? Do you have questions? Yeah? Now let me just say the key here is you don't mess up the order. If you mess up the order, the values will be wrong. So this is very order specific. This one is x2 minus x1. Then this is y2 minus y1, okay? But in the last portion, this is x1, and then this is y1, okay? All right, so we're gonna try to hit 2 birds with 1 stone. I want to work on more examples with you, but at the same time do the workbook. So go to page 84, if I'm not mistaken, and let's do more examples there. There are 2 of them, if I remember it correctly.
How are you?
Yeah, there's 2 examples there. So, oh, 89. I got the page wrong. My bad. 89. Okay, whenever you're ready. So let's start again. Number 1. So first, Let's find delta x, which is x2 minus x1. So you're going backwards. So your x2 is negative 4. Take away your x1 is negative 2. You see how this is so prone to errors? A lot of students write it as negative 4 minus 2, and then they lose one negative sign, and that changes the answer big time. So be very careful. Negative 4, take away negative 2. Final answer? Negative 2. That's perfect. Now let's pair up the y numbers. Delta y, what goes first? 1, take away 7, because you're getting the y numbers. So answer? Negative 6. Okay, so that's step 1. Next step, we change the ratio 3 to 1 into a decimal. So how do we do that again? 3, very good. It's not over 1 though. You have to add the 3 plus 1 together. So 3 plus 1 together becomes 4. So that 4 goes to the bottom. So it's always 0.75. Very good. So 0.75. Okay, and that's all we need. That's all we need to find the partitioning point. So to find the x value and to find the y value, we go back to x1. What is x1 in A?
It's
Negative 2 plus, what's the decimal? 0.75. And then what is delta x? Negative 2. Very good. Okay, help me with that, guys. And then y is, what's the y number of A? 7. No, that one first, huh?
Yeah.
So 7 from A plus 0.75, and then you use the negative 6 at the end. Okay, help me up with those two. Yes. Let me know if you got the answers. Okay, what did you get? What did you get? Be careful if you're using your negative. Huh? Yeah? Okay, so negative 3.5, and then what's the next one? Not there yet? Okay, I'll wait. 2.5, very good. All right, so be careful when entering that in the calculator. Okay, so now can you try 2 on your own? So as you can see, you can do it in 5 steps. Okay, now try number 2 on your own. Okay.
Nope.
I would do that so you don't use the negative sign.
But if it's not a negative, then
I would just make it right next to it.
That's it was right.
I don't have any proof for this. I have like no room on the page because my handwriting is so.
Okay. So for this one,
That's like being that's not design. Like if I was
Okay, anybody getting an answer either for both or just one of them?
and I was raised
Anyone?
The ratio thing is 0.4.
0.4. Yep. Okay, so the 2 is to 3 changes to 2 over 5, and Jesse said that's 0.4. That's a good start.
Where did that come from?
Where did that come from? It came from the 2 to 3, that's the ratio, and then we take the first number and then we divide it by the sum of both. So the sum is 5, then we take the first number 2. Yes? So, Nicola? If x is 2, all right. So can you tell me like the numbers that you plugged in over there?
What do you mean?
Like how did you get x?
Okay, well, 2 plus 3 is 5. And then 2 divided by 5 is 0.4. So that's how I got that part. And then...
Okay, but you began with 2, right? You said 2 plus, but here we have to start with the x one. Kendall?
The delta x?
Yeah, so this is your x1.
So you want me to go from the very start?
Yeah, so 3, 3 and then plus, you were right, 2 divided by 5 is 0.4. And then you're going to times it by the change in x. Can you help us with the change in x, please?
With for the delta x, I did 8 minus 3 equals 5.
Good.
And then for the delta y, I did negative 2 minus 1 equals negative 3.
All right, so negative 2, take away 1, that's negative 3. Perfect. So I think we should redo the x value. So you entered it correctly, except for maybe this one. Go ahead and help me find this, honey. So multiply 5 times 0.4, and then you add 3 after. And it will become 5. Okay.
Yeah.
Perfect. And then the y value equals. So let's get the y value of a. So 1 plus
0.4
times
negative 3.
-3. And the final answer is?
Negative 1.2.
Oh, I got negative 0.2 only. Okay, I'll try again. So maybe I'm the one that was wrong. So 1.
0.2. It's negative 0.2.
Okay, I got negative 0.2, honey. Can you verify, please?
I probably got it wrong.
My brain is just so.
Oh, I see. Okay. So this is 0.2. All right.
Negative energy and potential.
Okay, so the partitioning point is 5, comma, negative 0.2. All right, do you have any questions so far? Any questions? No? Okay. I think once you become familiar with the steps, it gets easier, right? Okay, it's just a matter of memorizing the steps. Okay. Next one. We are going to review some of the things we learned in Algebra 1. Kendall and Camille? Toa and Elena? Okay, so we're going to review some of the things we got from Algebra 1 last year in order to answer number 3. I decided, even in my other periods, I did not spend a whole day of lesson in this one because we already learned them previously. But I don't want to make an assumption, so we're going to review parallel and perpendicular lines for just a tiny little bit. Okay. So let's do parallel lines. This is number 3. So parallel lines and perpendicular lines. Okay, so first, can you tell us how are parallel lines related in Algebra 1? How are their slopes related? How are the slopes of parallel lines, Jolene? There is no slope. They do have slope, and how are they related? Yeah, good. They don't intersect because they have the same slope. Very good, Sebastian. So equal slope for parallel lines. So when Elena earlier said P and Q are parallel, right, Elena? You said P and Q are parallel. So let's support Elena's claim by finding the slopes of P and Q. So Sebastian said if two lines are parallel, they should have equal slopes. Why did I say equal lines here? Okay, so equal slopes. And then Elena claimed P and Q are parallel. So let's support her by finding evidence. Okay, so this is line P, right? Let's find 2 points on line P. I think we can go from here to the one in quadrant 2. Let's count the slope, shall we? Okay, so from here I could go down 1, 2, 3, and then to the left 1, 2, 3. Did that make sense?
No.
So we went down 3 and then left 3. Let me show that again. So I'm on line P. Okay, another point on P is this one. So I need to travel from here to there. So I'm going to count. 1, 2, down 3. And then I go 1, 2, left 3. Did that make sense? Rise over run, yeah? Okay, so negative 3 divided by negative 3 is positive 1. Okay, so now let's find the slope of Q. Can you do that, please? So go to this point and then count how many ways you're going to go down and over to get to this point 0, negative 4. It's the same thing. So 1, 2, down 3, 1, 2, left 3. Okay, so does that support Elena's claim that the two lines have the same slope? Yes. So we say P is parallel to Q. That's the correct symbol. P double bar Q. All right. So now, are they the only lines that are parallel? Or maybe the other lines are related in a different way. So what I'm going to ask you to do is help me find the slope of R, the slope of S, and the slope of T, just by counting rise over run. So can I give you about 1 minute and 30 to do that? Count the number of boxes. And don't just give us a final answer so we don't lose anybody. Tell me like how many times you went down or up and how many over left or right. Okay, who has R? This is decimal. What are the numbers? So R has these 2 points over here. So if you count, how many going downwards? 3. So down 3. How many over? 4. Okay. So let's just leave it at that. It's at negative 0.75, right? Okay.
No, it's not. Wait.
It's
Oh, wait,
not?
you're going up 4. Wait.
You're going down 3, and then you're going to the right 1, 2, 3, 4. Did that make
When
sense?
you're going to the left, it's negative.
It's negative, yes. Okay, what about S? What's the slope of S? We're expecting something negative because your line is going down again from left to right. So what's the slope?
-1.
Very good, Brian. So it's negative 3 over, so 1, 2, 3, and then 1, 2, 3 over. Okay, so negative 3 over 3, which is negative 1. Yeah, because we're going to the right. Okay, next, T. T. Very good. Negative 3 because we're going down, and then 4 to the right, so positive 4. Okay, now that we have all their slopes, I think we can conclude, we can make more conclusions as to whether they are parallel or perpendicular. So what else are parallel besides P and Q?
RT.
RT, very good. So R is parallel to T because they have the same slope. Perfect.
And Q and S.
Q and S are what? Parallel or perpendicular?
Parallel.
Parallel? I don't think a positive one and a
Oh, no,
negative
they're
one.
not. They're just perpendicular.
Good. Okay, they're perpendicular. So let's review perpendicular lines. In what ways are slopes related if they're perpendicular? In what ways are slopes of perpendicular lines related? Opposites. Very good. Opposite what? They're opposites of each other. One is positive and the other is negative. There's one more thing.
Opposites.
Opposite. Okay, the other word is opposite reciprocal. Do you remember that from Algebra 1 last year?
No.
Opposite reciprocal? Okay, let's review very quick. Okay, let's review really quick. I'm going to make a bubble over here. So if my original slope is 1/2, how do I do the opposite reciprocal of that one? 2/1. 2/1. Okay, then change the sign as well. So 2/1, but if this is positive, this should be the opposite, so it's going to be negative. So it's going to be -2. Did that make sense? Okay, another one. If I have a -2/5, how do I do the opposite reciprocal?
Positive 5
Over 2. Very good. So you're changing the sign and you're flipping the numbers over. If I have -6, what's the opposite reciprocal? +6. Try again. +1/6. Perfect. Because this has an over 1 underneath it. So you go flip it around. Okay. So that's why when you said P and S are perpendicular, this is 1, right? And then when you do the opposite of 1, it's going to be negative. But since 1 has a denominator 1, then when you flip it, it's just going to be the same thing. So that means P is perpendicular to S. This is the symbol for perpendicular. It's the inverted T. What other two things could be perpendicular?
Q and S.
Q and S, very good. So Q is perpendicular to S. All right. Okay. So we did all that just by using what we learned last year about parallel and perpendicular lines. Okay. All right. So using what we learned here, how can we conclude whether, or what possible conclusion can we make here? We have to know whether line 1 and line 2 are either parallel, perpendicular, or neither parallel nor perpendicular. Now how will we do that? Let me erase this one. So we have line 1 with those 2 points, and then you have another line 2. Your shoes new? Mine doesn't do that. Mine is old. Okay, so now you're going to find, or you have to justify why they are parallel, perpendicular, or neither. Help me out. What ideas you might have? Hey. Okay. Help me out. What can I do?
First, you're gonna do that one formula.
That one formula. I know. What's that formula?
The change in x and change in y.
Good. What do you call that? The change in y over change in x?
Yeah.
What do you call that? What does that give you? The change in y over change in x. The slope. Very good. Okay, so tell me, what is the slope of line 1? And you guys said it's the change in y over change in x. Okay. Help me out. And how much did the y's change? 2. Okay. So it's 2 minus 0 over, what's the over part?
Over
Negative
2.
2 minus 2, which is -4. So how do you simplify this?
How many times?
Good. So final answer would be -1/2, right? -1/2. Okay, now let's do the same thing. That formula, like you said, that formula with the change in y and change in x. Okay, so we can start with 4 take away -2, and then 4 take away 1. Okay, help me with that.
It would be 6/3.
6/3, which turns out to be
2.
2. Okay, so what conclusion can we make out of -1/2 and 2?
That they're not perpendicular.
Hmm?
I
You said they're not perpendicular.
I don't know.
They are perpendicular. So since, -1/2 and 2 are opposite reciprocals. Okay. So line 1, ooh, what was that? Line 1 is perpendicular to line 2. There you go. That's a lot of work, huh? Somebody asked me earlier, Miss, is there a shortcut to all of this? Yeah, actually, you don't have to show like the subtractions I do here. If you can do it in your head, you can just look at the numbers and say like, oh yeah, this minus this over this minus that, and you can get the final answer already. I mean, I just like showing all the solutions so you guys don't get lost. Okay. But if you're very good at mental math, you can just do them in your head.
I'm still lost.
Okay, please ask questions. If there's like something that was a little confusing before we move on. Do we have more time? Okay. Is that the last one on that page? Okay,
Yeah.
so we'll finish the other page in just a little bit. Do you have any more questions? Did you get confused? If yes, in what part? So we can go over it pretty quickly. How many formulas have we done today? The partitioning, the slope. There's one more, or there's 2 more. Sorry, guys. Okay. Okay, so, yes, But this lesson is more like algebra than geometry, huh? I just don't want to skip a lesson in the book, so. Okay. We're good? Okay. All right, let's move on to the next page. The last one. Oh, this one, you'll love this. This one is easier than what we just did.
This gonna be like
Hello.
Yes. Hi, are you?
Take a look at your picture.
Oh, thank God. Please, go ahead. Yeah. What am I going to do here? Okay, close this one. All right. So here we go. It's right here. The control is over here. Yes.
So I'm working on the one next door as well, but I can't do too much because I need to go get some nitrogen for that.
Okay.
So I'm going to start on yours.
Okay. All right. So let's work on this one. Write an equation of the line passing through point 3, -2. Do you remember something like this in Algebra 1 last year? Writing equation? Okay, let's slow down a little bit. Let's start with what we know. First, let's make a graph. Let's make a graph. Oh, I missed that line. Okay. Okay, so let's plot 3, -2. 3, -2. So 1, 2, 3, and then down 2. 1, 2. Okay, let's start with that. 3, -2. Okay, now what are they asking us to do? They're asking us to graph an equation that is parallel to the original line. But what is your original line? The original line is y equals 2/3 x minus 1, yeah? We want another line to be parallel. So what do we know about the slopes of parallel lines again? Equal. Very good. So they gotta be equal. So that means we have to use what slope? What's the slope?
The slope is 2 over 3.
2 over 3. Okay. So 2 over 3 meaning you go 2 up and then 3 over, correct? So let's count that from the first point. This is 3 negative 2. And then we count up 2 and then 3 over. 1, 2, 3. Put another dot there. What if you want another point? But I have no more space. Where can I go? Okay, you can go down 2, but you have to reverse the 3 also. You have to go left 3. Okay, so let's do that again from here. Down 2, left 3. There you go. And we got your line. But is that what they're asking us to do? Is that the only thing they're asking us to do? No, we graphed it. What else are we missing? Write an equation. Perfect. Okay, then help me write an equation. So the equation is in the form y equals mx plus b. What is the b in the graph? The y-intercept. And what is this y-intercept here? It's down 4. So 0, comma, negative 4. That's your y-intercept. What is your m? M is slope, which is 2/3. Very good. So that's all we need. So y equals, put the slope in, 2/3, copy your x, and what is our y-intercept? Negative 4. The y-intercept is the point where your graph hits the y-axis. Okay, so that's your final answer for the equation, and this is your graph as well. Oh, it said graph the lines, graph the equations of the lines to check that they're parallel. Okay, let's graph the other line. So, negative 1, and then 1, 2, 1, 2, 3. Then 1, 2, 1, 2. Do they look like they're parallel? I think so. So this is the original one. Do they look like they're parallel? Yeah. So the y-intercept is negative 1, and then we count the number, the same number for slope. Up 2 and then 3 over. Up 2 and then 3 over. Okay. Yeah. So this is the original line, and the blue one is the new line. Yeah, go ahead. What was the question? Sorry. Huh? This one or the green one? The green one. I looked at this one, right? So the y-intercept is negative 1. So this is 0, negative 1 right there. And then from there, I counted the same slope. Up 2 and then 3 over. Then up 2 and then 3 over. There you go. You're welcome. Okay. We have about 2 minutes remaining. We'll do the bottom 2 tomorrow. Is there 2 or just 1 left? 2. Oh, and the last one is a new lesson. Okay, so we'll continue with this tomorrow. Do not take a picture yet and upload it because I'm going to grade it all at the same time. So for tomorrow, we'll finish this off and we'll start having a study guide. We are going to have our test. Is Wednesday next week okay, guys? Monday is too soon. I want to be able to review before the test. So Wednesday is good, right? Yeah. Okay.